Okie smoky, this is number 18. It says to solve -2 times the absolute value of 3x plus 5 plus 7 is greater than or equal to -13. So now we have two things going on. We have an inequality and we have an absolute value. So what I'm going to do is I am going to rewrite this so it looks nicer. So -2 times the absolute value of 3x plus 5 plus 7 is greater than or equal to -13. You are going to try to isolate the absolute value. In order to do that, I'm going to subtract 7 off of both sides. So I get -2 times the absolute value of 3x plus 5 is greater than or equal to -13 plus a -7 is -20. Now I'm going to divide both sides by -2. And when I do that, I get the absolute value of 3x plus 5 is greater than or equal to 10. Okay, at this point you have two problems you need to work out. The first problem, we're going to remove the absolute value and just write 3x plus 5 is greater than or equal to 10. For the second problem, I'm going to keep the 3x plus 5, but I'm going to say that it is less than or equal to -10. So notice that when I use the -1, I had to switch the inequality sign with that one. Okay, so you have to do two things. Switch the inequality sign and make that value negative. Okay, all right, now I solve. So 3x is greater than or equal to, if I subtract 5 from both sides, I get 5. Now I'm dividing off by 3. I do not have to change my inequality sign because that coefficient in front of x is positive. So x is greater than or equal to 5/3. Okay, there's one of them. Now, I'm going to subtract 5 off of both sides. So 3x is less than or equal to -15. I'm going to divide both sides by 3. Again, because my coefficient was positive, I don't have to change the inequality sign at this point. -15 divided by 3 is -5. Okay, so I have two answers. X is less than or equal to -5, so all my x values are smaller than that. So I'm going to write -infinity to -5, including that value, union, and now it says that x has to be greater than or equal to 5/3. So 5/3 is going to be with the square bracket because it's included, going up to infinity. So with these inequalities, you're going to get two answers. All right, let's look at 19. 19 says 18 is less than the absolute value of 6 minus 3x. Okay, guys, so we have a less than this time around. When you have a less than, you can write this up as such. Let me see. So I have the middle, which is 6 minus 3x, is less than, and we're going to put -18 here, and less than +18 here. Okay? The way this one was written up, usually it's written up backwards, but I'm going to do it this way, okay? All right. So I'm going to subtract 6 off of both ends. And when I do that, I get -24 is less than -3x, which is less than 18 minus 6, which is 12. Okay? Now, here's an example where I have a coefficient that is negative in front of x. So I know that's going to affect both of my inequality signs. Okay? So I'm going to divide off -3. And when I do that, I get -24 divided by -3 is a +8. Change the inequality sign. Whoops. And then we have the x. Change the other inequality sign. And 12 divided by -3 is -4. Okay? So x has to be in between a value of -4 and 8. So if I rewrite this, it looks like this. Okay. All right. So now if I rewrite it in order, -4 is my smallest value, and it goes up to 8, and neither one of these are included in the solution. Okay, that was questions 18 and 19. I'm going to go ahead and do 20. Determine if a relation is a function and list the domain and range. So to check to see if a relation is a function, you have to check your x values. So I'm looking through my x values, and they are all different. There's no repetition. So it is a function. So the answer is yes. Now the domain is all possible x values. So we're going to do -3, -8, -1, and -5. So those are my domain. My range is my y values. So when I look at this, I get 2, 4, 2 and 4 are repeating again. So I just have to list them once. So the range is 2 and 4. Okay, so I'm done with that question. All right, so thanks for watching 18, 19, and 20.